Alright, this particular course is going to go over electric heat systems and PMAs. So we did one course on gas furnaces, so if you want to learn how to do a PMA on a gas furnace, it is another video that will be titled Gas Furnace PMAs. This particular video will be titled Electric Heat PMAs. So when you're doing a PMA on a system, not only are you going to check all of your features for your gas furnace and your electric heat system, but you're also going to go check the rest of your system, your return air, your filter sizes, your duct system, your collars, your air leakage, your drain lines, because we're going to blow drain lines when we do a PMA as well too. So we're going to focus right now on all of the checks that we have to do for an electric heat system when we go do a PMA. Again, I'm going to say a PMA is a preventative maintenance agreement. Now, all preventative maintenance agreements are prepaid. And when I say prepaid, they've already paid for them before you go there. So that would be considered what we call a PMA. If they send you to go do a quote-unquote service contract, customer purchases a service contract, which therefore gives them the benefit of 2 PMAs. So they say, I need you to go do a service contract for Mr. Joe. That means you are collecting for the service contract. On your phone, when you are dispatched out for a PMA, it is going to be a light blue. Okay? It may be a dark blue that will mean you're collecting for a PMA. Excuse me, collecting for a service contract. Okay? If you are going out, say today, and we never did do their spring PMA for whatever that reason is, and we're going today to do a spring and a fall, because we're going to do both of them when we get there, then you will have 2 dispatches, a spring and a fall. You will use 2 separate invoices, one for spring, one for fall. You're going to take the picture of your gauges. You're going to take the picture of your disconnect box, okay, with the wires that are in it, so that I can see that you literally have a number 6 wire up inside there, or 2 breakers up inside there with a 60 and a 30, and you got 15 kW heat. I want pictures that you cover your ass. So, you know, the guys we're training right now that are not on the video, they're out there, they're new to the game. So in order for me as a business owner to make sure that you are doing your job right, because I can't be in every house that you go into, I have to, 1, train you properly, and 2, I have to make sure that when you go there, you do everything I'm asking you to do, and then you don't pencil whip the paperwork. So if I send you out to do a spring PMA, and every time I send you out, you don't take pictures of the gauges, do I really know that you had a 12-degree subcoolant and a 10-degree superheat and this, that, and the other thing? No. You could just walk out to the truck and just write down anything you want to write down. And then we go out 2 weeks later, and it don't have a 10-degree subcoolant. It's got a 1-degree subcoolant. And you put all these goofy-ass pressures and temperatures on it and make it sound fine. You didn't take a picture of it. And we go 2 weeks later, and this guy has a picture of it. And they said, hey, he went out there and he said all these is pressure. So either we got a big leak that happened in the last 2 weeks, or he lied. I'm going to go for he lied. And he pencil whipped the paperwork. Now, depending upon who you are, well, I believe that it's really and truly, that's honest. Depending on who you are, do I believe you're just lazy and pencil whip the paperwork? Or did you really write down what you've seen? And will you sit there and argue with me that, look, I'm looking at a picture of gauges that Joe Blow went out there today, you went out there 2 weeks ago, and here's what you wrote on your pressures. Tell me how they're that far apart in 2 weeks. Okay. You're going to have to give me an explanation, because I just don't believe you unless I see a picture of your gauges. Now, Mitch went out to a job, and I'm looking at his gauges and I'm going, there's no way that these pressures are this effed up. So I went out there with him on the system and we put gauges on the system, and they were completely different pressures. Now, if he wouldn't have took a picture of these gauges, there's no way I would have believed him that he was running a 410-pound head pressure with whatever, okay? There's no way he could have ever told me, because 2-3 days later, him and I went back over there, and I put gauges on the system, and I'm reading, you know, decent pressures or whatever. It was actually low on refrigerant. But his pressures, and he had a picture of them. They were so effed up. I'm like, dude, how'd you leave the unit like this? We got to go back and go see. So we went back, and I'm like, you got a picture. I can't dispute your picture. Now, what happened to your gauges at that point that were reading those kind of pressures, I don't know, but you uploaded them right when you did it. So, what happened with that one, I don't know. But guys, you got to take pictures. Trust me, everything that you do, you want to take a picture, okay? You want to take a picture of the condenser, upload a picture of the condenser. Take a picture from here to the end of the wall, 10, 12 feet away, of the installation. I want to be able to see how is that system installed from a distance, so I can see the furnace, the coil, the plenum, and just kind of get me the whole picture of it. So if I ever got to look back at that system to see how it was installed, either to give them a price on a new one, or just kind of see what you may or may not have missed by me looking at the full installation. That tells me a lot. So trust me, guys, pictures, 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 that covers your ass in everything that you're doing, okay? Take a picture, I don't know, fuse sizes, wire sizes, bloop, upload, there you go. 10 kW heat system, and you can list it, 10 kW heat, 60 amp breakers, boom. I can't dispute what you're doing now. That's telling me you know what you're doing. And that's telling me that you took a picture showing, hey Art, I got a 60 amp breaker, I got number 6 wire, 10 kW heat system. Boom, took a picture of it and labeled it just like that. And I see your wires are not burnt, zoom in on them, there's nothing burnt, system good. You keep doing that, and then you turn one end that's burned up and you go, burnt wires, need new disconnect box, customer wants to replace, $384, whatever, okay? That's on your invoice. You took a picture of the burnt wires, you replaced it, you took a picture of the new one, boom. And I'm going, this dude's doing it right. I ain't gotta worry about him. It's the one that doesn't do it right all the time and always wants to shortcut everything that I gotta go behind constantly and don't believe anything they say, okay? It is much easier for you. Just follow all these instructions, especially being new at it, man. I'm gonna, before I get into this real quick, you know I get on rants, right? I can train you how to be a good technician. What I can't do is I can't force you to be a good technician. I can teach you what it takes to be a good technician. I can teach you what it takes to make a lot of money in this business. I've been in this business a long time. I've made a lot of money in this business. Have made my family very well off from the money I've made in this business. You're just starting in this business, okay? You're 27. I was 25 when I got in the business. I can teach you how to get where I am at 55, okay? So, hard work, dedication, but more than anything, you gotta have a way to go. You gotta have a pathway. And then don't waver from that pathway. If it works, why waver from it? Why reinvent the wheel? If I can tell you how to make money in this business, and I can prove to you how to make money in this business, then why wouldn't you do the same thing if you want to make money? If you want to be a really good technician, it is this simple how to be a good technician in this business. Because the bar is set about this high in this business as far as being a good technician, okay? It's about that high. You want to be a good technician, the number one thing that you need to do is you need to be the most thorough person you can be when you go to a job. Because being thorough, you are going to find 100 times more things than everybody else who is lazy. Second thing is you need the correct tools. You need the correct meters, you need the correct gauges. You need leak detectors, you need carbon monoxide detectors, you need manometers to check static pressure, you need everything you need, you will use and you will make money off of it, and every tool you buy will pay for itself. So don't be cheap on tools. Don't be cheap on your meters. Take care of them, put them back in the case. Don't leave them in the truck. Take care of everything that you do. Utilize your tools when you go to the job, and then learn, as I said earlier today, learn a presentation for everything that you do, as long as you're not lying to the customer, cheating them, or stealing from them, and you're just selling enhancements to their home, better indoor air quality in their house, safety features for their disconnect boxes with surge protectors, hard start kits, high and low pressure switches, blowout valves, float switches on their drain line, new supply plenums because they're full of mold and mildew, new ductwork because it's old and just nasty. As long as you are upgrading somebody's home and giving them the opportunity to do it or not do it, and you're not lying to them about anything, and you got a picture to prove that the plenum's disgusting. Do you want to keep this in your house, or would you like me to give you a price on a replacement? Do it right. Just do it right. And if you don't lie, don't cheat, don't steal, you never got anything to worry about. You never got to wonder what you said. And the other part of it, besides learning a presentation, is actually learn what you're doing. I have sold so many jobs because I can explain everything properly, okay? And I actually know why I'm telling you what I'm telling you. Now, in the end, you may go with this other guy because he's cheaper. That's fine, no problem. But I also get a lot of work because I explain things to the customer, and the other guy who was there could not explain anything. He just gave a cheap price, and he showed up in a truck that's not marked. He shows up in, not a uniform. He's got a baseball cap on with his baseball shirt and flip-flops on, and he's going to give him a price on an air conditioning system. So how you present yourself, all that kind of stuff just goes hand in hand with everything that we do. All right, rant's over with. Let's go into electric heat systems. Again, on electric heat system, the bottom portion of this from here on down is the electric heat system. This little portion right here, that's strictly electric heat we're going over right now. The bottom part of this invoice is for airflow, and then the right side right here is all your duct system, collars, air leakage, drain lines, that type of stuff. So we're going to start out with electric heat. And again, on this checklist, a lot of it is going to be okay, fair, poor. And I'm telling you, on this sheet right here, which is my fall PMA sheet for electric heat systems, I'm telling you what I'm asking you to go look for when you go do a fall PMA. I'm not just throwing you out in the field and saying, hey, go check that electric heat system, and you go turn it on. Okay, it runs. You didn't do a fall check then, if you just turned it on, okay? So the first deal on it is electric heat is check the condition of the air handler. What am I asking you to do? What is the condition of that air handler? It's horizontal. And because it's horizontal, the emergency pan underneath it is completely rotted out. Well, hey, I don't see anything on here looking for a drain pan. Well, yes, I do, all the way on the right-hand side. They got drain pan on there, okay? And if your drain pan is rotted, guess what? You need to make a recommendation to replace the drain pan. Then you got to ask yourself, why is the drain pan rotted? What's causing the drain pan to be rotted? Do they have a downflow on their drain line? Then you look at the condition of the air handler. They have two supports underneath that air handler. So here's your air handler here. So there's a line right in the middle here. Your evaporator coil is here, and your blower motor is here, and your heating elements are here. And then there's the support right here, and then there's the support right here. And they're right in the middle of your air handler, which is going to cause this to bow like that, and this to bow like this, because my support is in the middle on the corners. That's where my support is. But instead of putting a total of 6 blocks underneath here, whoever it was put 2 blocks, and well, 4, one on each side of them. So I would put a block here, and a block here. We have foam blocks, and that would be on each side, so a total of 6 blocks. and I would put those blocks under the corners so that is where your support is. That's going to keep your air handler straight. If I put the blocks here and it bows, then your door stays straight, but the air handler bottom of it kind of bows up, and then you have air leakage seeping from there. Okay? Now that sucks in attic air. Alright? So what is the condition of that air handler? Is it all rusted? Is the drain pan rusted? Is there shit sitting all on top of the air handler? Is there luggage all up on top of it? Okay? Does the wire coming in here have a Romex connector on it? What size wire is coming in here? Is it a number 6 wire? Is it a number 8 wire, 10 wire, 4 wire? What is it? Does it have a Romex? What size breaker do you have coming from here? So when I'm asking you the condition of the air handler, I'm actually asking you the condition of the whole damn install, ain't I? Yeah. Not just the physical box right here, right? What is the condition of the air handler? What is the condition of it? That's what I'm asking you. Look at it. Transition comes out from here, and then the plenum comes out this way. And then they got all this blocked off right here. I'm going, damn, whoever installed this freaking thing ain't working. They stupid, okay? I look at my drain line, my drain pan sits underneath here. And it sits on top of plywood right here. And then my downflow from my drain line is 2 inches. And then it runs out here and runs 20 feet over that way. What's the condition of my air handler, guys?
Poor.
What if my return air is right here? Return plenum comes down like that. Air handler butted up against my return plenum. It's not supposed to butt up against your return plenum. Why? Because my drain pan can only go up against the return plenum, right? I need a transition in between my return plenum. I need a transition in between, and now my air handler can start, so my drain pan can go up underneath here, so if I get water dripping, it drips in my pan and not down my return plenum. It's finally raining. It's been a while since it rained. Check that out. You need that at the camp. You need to get that food plot growing. So if there's no transition and the drain pan doesn't go all the way over to it, what is the condition of your air handler?
It's poor.
No downflow on your drain line. Drain line's not insulated. No float switches. Drain pan's rusted on the system. System is not raised at all. Plenum's kind of blocked out. I'm going to put condition poor. End story.
And recommended and priced up.
That is correct. But your first thing, what I'm saying is you can't pencil whip all the stuff that we're talking about. What am I asking you to look at? I'm asking you to look at the whole installation of it. Just on the first one is condition. What's the condition of your air handler? And it's not just the case. Well, the case looks nice. The condition of the air handler is okay. No, it ain't. Right? So, condition good means that the installation of the air handler is good condition. Condition fair means that the installation may have no catwalk. The cabinet is mildewed, drain has no insulation, hard to service based on installation, it's dirty around the air handler. It's fair, it's not totally bad, right? Poor. The air handler is rusted, doors don't fit properly, electrical is not secured with the Romex connector, supply is blocked off, platform is rotted, can't service system because the space system is unsafe. That's poor. That's what I'm telling you. If it says poor, what should be your recommendation?
Change out the air handler.
Change out the air handler or replace the entire system. Or it could be the installation is completely poor, but the actual air handler is 2 years old. Then your recommendation would be reinstall the air handler properly. Okay? Next, wiring. Check wiring for proper size, condition, tighten wires on all breakers, air handlers, and disconnect boxes. Look for discolored fuses, burnt or charred wires. So number 2 is wires. You're checking wires. And I'm asking you, are they okay? Are they burned? Are they miswired? Well, what are you doing? What am I actually checking for on the wires? There's no Romex connector. This goes into a breaker box right here. And then as the breaker is sitting up here, right? Well, your wires come in here, right? And they bypassed the breaker and just brought the wires right on up here. No, we need to do disconnect box. Okay? Wires. They're
Miswired.
not burned. They're miswired. You circle miswired. Okay? So miswired. Heating system does not work due to miswiring, or either low or high voltage wires are messed up, basically, and that would be considered messed up. Okay? You don't have a float switch. Should you have a float switch on every drain pan?
Yes.
Yes. Should you have a float switch on your main drain line?
Yes.
Yes. Okay. Okay, proper wire size, Romex connectors on, wires are secure, nothing is burned. Miswired, heating system does not work due to miswiring or either low or high voltage. Burn means the wires are burned, bad connections. So this right here goes into a breaker, okay? Here's your breaker right here, guys. Then this goes into your electric heat system and powers up your heating elements, right? If this cabinet door does not have a plastic cover over this breaker, tell me what's going to happen.
It's gonna get moisture.
Say again?
It's gonna get moisture.
It's going to get moisture. Why?
So we don't have no cover.
Because there's no cover. How is
Because
it
of
going to
the-
get moisture? Where's the moisture coming from?
From the coils, from the evaporator coils.
What's happening is your blower is taking the cold, humid air off of this evaporator coil, and inside this blower, the heating element compartment right here, like if I take this door off right here and I run my heating elements, you can literally see light through there, all the little pieces of all that kind of stuff through there, and you can literally see the glowing of the coils through all the little bitty holes in there. So what's happening is that blower is giving a positive pressure into this air handler electrical heating element space, which is blowing air out, and you got hot, humid air from the attic is seeping in, and it's hitting at the breaker. And the breaker's sweating. The breaker sweats, and then all of your terminals are all rusted. It's going to rust out that breaker. You have to replace the breaker. Okay? So you always want to check that. And we have extra rubber pieces that we can put over there, but we don't give them away. We sell them. Okay? Unless we install the system, because they should have them on our systems. If somebody else's, put it over it. If it's an old one, you sell it, you put on it, and you put a new breaker in. Okay? Because that's how you're going to stop that that new breaker from condensating and having everything chewed up. You can also put some electrical liquid tape on it in order to help prevent that electrical in there, or some oil, not oil, but grease on your electrical connections up inside there in order to help it not sweat and cause rust all in it, okay? Electrical
Price
grease.
range for that case is in here?
No, they cost about $6, $7, $8 or so. You know, you can sell it for $50 or something like that, $40, $50 or whatever, you know. Okay. Okay, number 3, heat sequencers. Okay, this is a heat sequencer. This is a heat sequencer. This is a double heat sequencer, as you can see. This would be a single one. This one here is broken. The top is broken on it. So you would supply voltage to this side and this side for low voltage, your W, your common, to here. That will then energize and then close your normally open switches here, normally open switches here. And because you have a total of 2, 4, 6, 8 total openings on here, 4 total openings on here, normally open switches, when you energize them, they are going to energize up 1, 2, 3, 4, okay? And then they will close back on 1, 2, 3, 4 as well too. So as it opens one way, it'll close back the other way, all right? The reason they do that is so that you don't have each 5 kW heat strip turn on at the same time and cause a power surge. That's the reason you do that, okay? This heat sequencer used to have another pole on top of it, which was, this is one that literally comes from like a Goodman unit, and there was another pole on top of it that had one spade up on top of it. This is the only one that I've seen that is a normally open, normally closed heat sequencer. So if you see one with 3 poles as opposed to, say, 4 poles like this, that could be, probably is, a normally open, which would, these two would be normally open, and then these two would be, I'm sorry, these two would be normally closed, and these two would be normally open. And then you use this as your common. And that would be normally closed, and that would be normally open. And you could use that as a fan relay with a normally open, normally closed switch. So heat sequencers, when you apply power to them, close the heat sequencer, which turns the heating element on. These will be good or bad. You apply voltage, it closes. You know, if you apply voltage and it don't close, replace your heat sequencer. All right. Turn on the heating elements. Check voltage is crossing the heat sequencer, and the heat sequencer is working. All elements should draw amperage. Okay, simple means it works. Burned. Wires have burned on the heat sequencer. Replace the heat sequencer. So you got to remember, on the top of these heat sequencers, on all these plugs, if you don't have good connections onto them, and you're drawing 5 kW heat, which is drawing about 22 amps on 5 kW heat, then if you don't have a good connection on that wire, it's going to start burning that wire. If it starts burning the wire off the heat sequencer, you're also burning the connection in the heat sequencer. So if that wire is pretty much burning off the heat sequencer, you may want to replace the heat sequencer as well too, because if not, you'll probably be back replacing it. So replace the heat sequencer with the wire when it's burning like that. Open means that the heat sequencer does not close when energized. That's simple. Heating elements. Check what size they are. Hint. Count the setup in electrical compartment. Look to see how many limit switches there are. Heat sequencers. Breaker sizes. What amps does it draw? How many wires of one color are drawing amps? Add the amps or all wires drawing amperage. Verify the total amps. The correct kW heating elements in the system. Verify wire sizes for correct heating elements. If they do not match, figure out why. Okay, this is where we go into detail on heating systems and heating elements, guys, because wire sizes and heating elements and understanding what kW heat and what wire sizes is so important, because if you get this wrong and you do not understand this and you burn somebody's house down and you kill a little kid, you will not live really well for the rest of your life. And I want to kill you too. All right. So, if you have not written this down somewhere, you need to write this down somewhere, okay? So we're going to start off and we're going to go 5 kW. And we're going 7.5. Actually, we'll start off with a 3.5 kW. 7.5, 10 kW, 12.5 kW, 15 kW, 20 kW. That is about as high as we're going to go with residential air conditioning and heating with electric heat strips, is about 20 kW. I've never been in a home that had more than 20 kW, because then you're going into commercial with 7.5 ton systems, okay? So the first thing I want you to understand, I want you to think about two of these particular ones, and I want you to memorize 2 of them. If you can memorize 2 of them, we can pretty much figure out the rest of them, okay? Because 2 of them will make sense for all the rest of them. The 2 I want you to remember is going to be the 10 kW one and the 5 kW one. Those are our memory sticks, okay? Now, if I have a 10 kW system, now I want to know how many amps 10 kW draws. Well, I just need to know this number off the top of my head, and it's going to be in the neighborhood of about 42 amps, and that is going to be determined by your 5 kW heat and how many volts you have into it, and then you do your multiplication and your division, and you come up to somewhere in the neighborhood of 42. Now, that could include also your blower motor in with that 42 amps, okay? If you got 208 volts as opposed to 240 volts, you draw less amperage as your voltage goes up. Look up Ohm's law and you figure that out. Go to 5 kW. Well, hell, if 10 draws 42, I'm going to cut this in half pretty much, and I'm just going to call it 22 on 5 kW. Okay, well that's pretty easy. Okay, now I need to know also if I'm drawing 42 amps, what breaker size do I need to hold 42 amps? Well, I can only apply 80% of the load of that system onto a breaker. So by doing that, can I put a 40 amp breaker on there? No, it's drawing 42 amps, can't do that. Can I put a 50 amp? No, that's above 80% for sure. How about a 60 amp breaker? So let's go ahead and we're going to put a 60 amp breaker on a 10 kW system, and that 10 kW system is going to draw 42 amps. So we're going to go 60 amp breaker. So hell, let's cut this in half now. We're going to go 30 amp breaker, right? Alright, so that's my breaker size. Remember, I am only asking you to memorize 2 of these. I'm not asking you to memorize the entire chart. Remember 2 of them, the rest of them fall in place. What size wire would I run into a 60 amp breaker to hold 42 amps? It is going to be a number 6 wire. What size do I need for 30 amp? Number 10 wire. Alright. What else do we need to know across the board here, guys? 10 kW, 42 amp, 60 amp breaker, number 6 wire. Anything else we need to know?
You could run you could run 2 number 10s on them.
No.
You can't run 2 number 10s.
No, because you're going to have a 60 amp breaker.
Oh.
Yeah, you're not going to have 2 30 amp breakers for a 10 kW heat system. You're going to have a 60 amp breaker. Okay, that's why. Alright. So you got a 30 amp breaker, number 10 wire. Alright, so I'm good there. Okay, I'm going to jump this up to all the way at 20 kW. Well, let's continue down. Let's actually make this kind of in the middle of all this here. Let's go in the middle. I got a number 6 wire with 7.5 kW heat on 10 kW heat, and I'm 7.5 now. I got a 10 wire here and a 6 wire here. How about if I stick a number 8 wire in 7.5 kW? Can we do that? Well, between 60 amp breaker and a 30 amp breaker, what if I put a 45 amp breaker for 7.5 kW? What if I go in the middle and call it 31 amps? Am I okay? Yeah, I'm okay. Alright, well let's go step up this way now. We're going to go to a number 12 wire. Alright, what amp breaker here? Well, number 12 wire holds 20 amps. Well, if I'm going 31, 22, 80% of 20, I'm going to call it around 15 amps or so, 14 amps, in that ballpark area, right? Okay, that's about what it's going to... Remember, you don't have to be an exact. If you want to be exact, go to Ohm's Law and go 242 volts with 3.5 kW heat is 13.6 amps. Okay, big deal. It's about 15. Alright? Alright. We threw an extra one in here that's not in the paperwork on a 12.5. We're going to skip it. We're going to go back to it for a second, okay? So here's a number 6 wire. Okay? Now we're going to go to 15 kW heat. And we're going to come all the way over here. And what's my next wire size up? 4 wire. Then we're going to go to number 2 wire for a 20 kW heat system. Okay? Let's take this on back. And we're going to go number 4. Hell, we're going to do 80 amp breaker. And if I'm going 42 and I'm going to 15 and I go 42, 22, because part of this 42 and 22 is kind of your blower motor in there as well. you're somewhere in the neighborhood of about 62, 63, 64 amps in there for a 15 kW heat system. Remember, part of this amperage draw is actually your blower motor, not just the heating element by itself, okay? Because when you take your amperage draw, you got to take the amperage draw of the whole system drawing it, right? It's got to have your blower motor in there. All right, 20 kW. Well, hell, I got number 2 wire now. That's going to be a 100 amp breaker. How many amps is that going to draw? Boom, boom. 84 amps. Okay. Now, how am I going to figure out a 12.5? Well, shit, it's right in the middle of the two, right? We're going to call it 52 amps. That's what we're going to call it. 12.5, 52. That's exactly what we're going to call it. Look, I said 55. 52. Okay, 12.5 kW, guys. What are you going to do with that now? What breaker size you putting on it? What wire size you putting on it? I just threw a curveball at you because I never gave you the answers to this. 12.5
60 amp and a
kW.
30 amp?
60 and a 30?
No.
If I'm running one wire size to it, am I going to bring a number 6 wire on 12.5 kW? It's 52 amps. It's holding 60 amp breaker. Will it hold it? Yes. It would hold it. Is it too tight?
Yeah,
It's too tight.
too tight.
So if I'm going to do that, I'm still going to run a number 4 wire. But I might put a 70 amp breaker. Okay? Because your wire size you don't want to burn, guys. It's okay if I put a lower amp breaker on a higher wire. Okay? Not too often do you see number 4 and number 2 wire run into the air handler. Not too often do you see that. And the reason is because the price of those wires just is high. So what they'll do, instead of running a number 2 wire into a 20 kW heat system, they just go 2 number 6 wires for 2 10 kW heat systems. So this one here now becomes number 6 with 2 60 amp breakers. Now we have holding 10 kW each at 42 and 42. Now I have 20 kW heat on 2 number 6 wires, and they're separated. There is not any kind of jumper over or anything like that, okay? It's just 2 separate wires, 2 disconnects, everything. Now, if you have one breaker, 100 amp breaker feeding 20 kW, then you would have this terminal, L1, L2, okay? Then this would come up like this, and this would come down like this. I'll jump that over. So now I have an L1, L2, L1, L2, and then my breakers go into there. 2 60 amp breakers. And then it can go into the system from there. Or you have one 100 amp breaker, and if you've got one 100 amp breaker, then you have one breaker like this. Terminal here, right? L1, L2. And then your spades on the back of it do what? Your heating elements are tied into here, L1, L2. Run through your heating elements, right? 2, 3, 4, boom. And that feeds one. Or you do it like this with one wire inside the air handler, and then you have this is a metal terminal block basically that you put in there, and this literally screws now into breakers. And then these breakers go into your system. So as I was feeding this system, and all I have is a number 2 wire to feed in here, the system comes with 2 60 amp breakers. So I need this terminal plug to plug into all my breakers, screw all those down with two big lugs on here so I can tie two number 2 wires into here is what I need to do. That's how that would work. Okay? 15 kW. What do we need to do with 15 kW? What wire sizes and all that kind of crap we need to do with it? We need a 60 amp breaker and a 30 amp breaker. Because I want to take a 10 kW and a 5 kW and now I want to make it a 15 kW, right? And then now we got breaker size. We got a number 6 wire here and a number 10 wire here to feed those systems. Okay? Or you can have one 4 wire into an 80 amp breaker like this. Or it may come like this and you need it here. Why do I tell you you only have to remember 2 of these? 10 and 5. You only have to remember those 2. Because if you remember those 2, the rest fall in place. Look at your numbers. Look, if you know wire sizes, the wire sizes are going 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Okay, well that's kind of easy to remember. There's no odd numbers in there, no big deal. Well, hell, I got 22 amps and 42 amps. Well, hell, if I got 15, I add this one plus this one, that gives me 15. If I got 20, I add these 2 together, it gives me there. This is pretty easy. Just remember 2. Everything about 2 of them. That's it. And the rest of them, now you will be able to picture this in your head every freaking time now if you just remember 2 of them. Because if you don't remember 2 of them, what are you doing? You're scrounging because you don't know what you're looking at. Okay? Amperage draw total is number 5. This total amperage of all heating elements, the amperage draw is approximate and includes the blower motor running as well. If it is a couple amps off, it's okay. So 42 means your total amps is 42. So on my checklist here, I've got amperage draw and I have 42, 64, and 85 on here already, okay? And then above it, I have number 10 wire, or 10 kW heat, I'm sorry, 15 kW heat, and 20 kW heat, because that is most of the time what we run across. So all you got to do is circle what I'm telling you. If it's 10 kW, it should be 42 amps. You're not going to get a 10 kW system drawing 64 amps. It's not going to happen. Okay? If you have a 5 kW heat system, what do? Where it says 10 on there, just write 5. Where it says 42 amps, write 22 amps. That's all. This ain't rocket science. Okay? So a 5 kW heat system draws about 20 amps, number 10 wire. One 5 kW heating element drawing about 20 amps. 7.5, about 32 amps, number 8 wire with 2 3.5 kW heating elements drawing 15 amps each. Fan relay is number 6. Does the fan come on either by circuit board, relay, or heat sequencer? Okay, if there's no problem. If the fan relay is open, it doesn't close, that means your fan relay will not come on after 24 volts is applied to the coil. Relay is open. Replace the board or the relay. If it's closed and will not open, that means your fan will not shut off. If your fan doesn't shut off and it's the relay causing it, replace your relay or your board, whatever needs to be replaced. Number 7, circuit board. Is it mounted properly and secure? Is it okay? Does it work fine? Is it bad, not sending voltage to the fan relay and other components? Is it miswired? The wires are not in the correct location causing malfunctions. If that's the case, look at the wiring diagram and actually hook them up correctly and make it run properly. So the customer may call you out and they called you because somebody was just there and they can't get it running, and whoever was there pulled all the wires off of the circuit board and now you have got to re-put them back on. And you go over there and you got wires just dangling down and nothing is attached to the circuit board. So what are you doing now? And guess what? On the door of the furnace, you can't actually read the wiring diagram. Now what are you gonna do? You can't read the wiring diagram. You can't see it. What are you gonna do now?
You look it up, the model number?
Well, damn. You can't even read the model number of the unit. Now what are you gonna do?
Look at the wire sizes.
Wire sizes aren't telling you anything. In this particular case, I'm going to tell you what I was thinking of was a gas furnace. Because you got wires all over the place now. Plugs got to plug in where it plugs at, right? You remember I tell you that if you can remember, if you can draw something, then you can do it. Okay? We just got finished with a video on gas furnaces. I think I can draw how all my wires go because I know where they're going to, right? If you got a 16-pin plug or something, well, all your safety devices and everything are going into a plug. Oh, I guess it goes into the 16-pin plug. Okay. Well, you take your 2 wires and go to your IDM motor, and one of them is going to IDM motor, and the other one goes to a neutral. All right, that's fine. I can figure that one out. Okay. Orange wire from the flame sensor. Well, I'm going to bring that to one that says flame sensor on the circuit board. All your blower wires are off on the system. Well, now you got to look at them and go, what color are my wires? It's 220 volt, 115 volt, whatever. What color wires do I have? And I'm going to tell you, if it's a 110 volt system, your white wire is going to be your common wire. Your black wire is high speed. Your blue wire is going to be medium high. Your yellow is going to be medium low, and your red is going to be low. Your 2 brown wires go to your capacitor. On your circuit board, your black wire, high speed, will normally, not all the time, normally go to your cool, depending upon the tonnage of that system and the model number as we have described in other videos. Your low speed will probably be your heater, depending upon the BTU capacity of the heater, how big your house is, how leaky your house is, the whole 9 yards. Your M1, M2 on your circuit board will probably be your yellow and your blue wire, because those are parks. Your SEC, secondary, is going to be your blue and yellow wire from your secondary from your transformer onto your circuit board. Your L1 is going to be what? Your power going into your circuit board. Then there's going to be L1 next to it, which will be the power coming from your switch to your board, and then from your board to your transformer. That's all high voltage. Where's your neutral wire go? Your white wire coming from your switch.
L2?
No, it's a circuit board. It's a gas heat system in this case. So there is no L2, it's the neutral. So it's going to go to your neutral on your board in this particular case. Okay? I don't think there's any more wires left, guys. Okay? You just start learning where all the wires are, because how many circuit boards have I replaced in my career? Now I can just, I used to mark every wire. Boy, I'd take a picture of it or whatever, and I'd mark every wire, and I wasn't sure where it went. Then after you do it 80 to 100 times, you're going, let me just pull all these damn wires off here. Get them off, get the circuit board out of the way, put a new circuit board in, and then you go, okay, this wire's going here, this wire's going there. Because when you got 4 black wires, are they going to the correct place every time? Because you can literally move your IDM motor and plug your black fan motor into your IDM motor, and you turn your furnace on, and what happens? Your blower motor comes on. Well, a lot of times your spades on those are different sizes too, so you don't screw them up as well too. Okay? So that's your circuit board, guys. If it's miswired, wire it correctly, look at your wiring diagram. But you have a good point. If you know the model number of that system, then you can actually look up the wiring diagram of that system on your phone. On today, you can look up everything online, Limit switches is number 8. We are dealing with electric heat systems in this particular video here. And limit switches is absolutely your most important switch on an electric heat system, because it is your only safety device on an electric heat system. A gas furnace had rollout switches, limit switches, blower motor switches, negative pressure switches in order to help prevent fire, right? Well, here we have one limit switch that is protecting your system. Because the heating element just gets voltage to it, and the resistance of the heating element just energizes that heating element is all it does, and it lights up and it's glowing because of the heat on it, right? If you never put a blower motor on that heating element, will it just continue to run, or will it eventually, I'm saying eventually, pop? It would probably eventually pop. And if it popped, then you got no voltage. Well, you got voltage to it, I'm sorry, but you have no amperage, okay? If it pops and the spring falls and hits something and grounds out, then what happens? Trips breaker. System's off now. A gas heating system, you don't check your limit switches and your blower motor doesn't run, and your gas furnace is running, then you can have a whole bunch of heat up inside that chamber. So that's why you have multiple heat sequencers, limit switches up in a gas heat system. Here we have an electric heat system, so we have to test the limit switch. And how do we test the limit switch? We go to the blower motor, we disconnect the blower motor. Is one of the first things I do with an electric heat system. Well, let me take a step back for a second, because I should have said this in the other video for the gas heat systems. One of the things I'm trying to teach you guys is what protocol do you have to follow on every call you go to, on every PMA you go to, every service call you go to. There has to be a checklist for yourself of what do I do first, second, third, 10th, 12th, okay? The first thing that you have to do when you walk into that customer's house is, besides greeting them and presenting yourself and all that kind of stuff, is you turn the heater on. And when you turn that heater on, I want you to take the door off to where you can see the heating elements in there. But before you turn the heater on, the first thing I want you to do is look at the wires. Make sure you don't have any burnt wires before you even turn the heater on. Okay? Before you put power to this system and start running that heating system, you literally need to go ahead and pull the cover off where the heating elements are, and pull your where your breakers are, or your fuses and all that kind of stuff, and just look at your wires and make sure you don't have burnt wires before you fixing to apply all this load to it. If you got burnt wires, then stop. You need to tell them you need to replace these burnt wires. Don't go any further. Replace the burnt wires and then you go from there. Okay, or fix the disconnect box or whatever it is. So let's just say all that looks good. Then you turn your heater on, you put your amp probe on it, and I want to make sure that your heater actually comes on before you do anything to this system. Okay? Does your heating element come on, or does your gas furnace come on? Does everything ignite? Does your burner come on? Does it run? Does your blower motor come on now? And am I heating the home? If the answer to all those questions are yes, then when you leave, guess what the last thing you need to do is? Run that heating system again and test it before you. The last thing you do is go to your thermostat, turn it back on before you leave, and then you go, okay, heater's working again before I walk out the door. Because what if you forgot to put that red lead back on your blower motor and your blower motor don't come back on? It's because you forgot to put it back on. So you were testing the blower motor for high speed, right? And you forgot to put the low speed back on it. So now, what's going to happen when you try to run your air conditioning system? The blower motor's not going to come on because you took the blower lead off of it and didn't put them back on together. So now before you walk out the door, you're going to test the air conditioning system as well. Why are you testing the air conditioning system? You're there to check the heater.
Just to make sure you put your cooling.
Because you want to make sure you didn't screw something up before you left. CYA, cover your ass. Alright? Not only am I going to turn the air conditioner on, but I'm actually going to go outside to make sure the compressor and the fan motor came on outside. I will grab, if I'm inside a vertical closet or something, I will grab the liquid line and suction line, and when I turn it on, you can hear the compressor come on 99% of the time, right? When it comes on, you're listening to it, compressor came on, okay. and then you can feel
The flow.
the flow of the refrigerant through your suction line or liquid line, and I go, okay, condenser's running. Because what if you blew the drain line and you pushed up the float switch and you didn't realize it? Or when you put the float switch back in, it cocked a little bit and it shut off. So you finish your heater check, you didn't check anything after the fact, you wrote your paperwork, see you later ma'am, everything's working fine. 3 hours later, she's hot in her house, she's mad because you just went out there and it was running before you got there and blah, 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 blah.
It's a mess.
It's a mess. And all you had to do was turn the heater on before you left, then turn the heater off, then turn the air conditioner on and make sure the compressor came on, fan motor came on, and then ask them what temperature did you want me to set this thing at before I leave. Now, she is not calling you 3 hours later saying it's not cooling. It's not happening. But if you screwed something up inside there and you do not check this before you leave, we will get callbacks on you. Okay? It happens to the best of us. Okay? So, limit switches is where I got off on a rant. I'm going to read what it says on here. These are round discs with connectors on each end. High voltage power passes through the heating element. This switch opens when the heat is too high in the air handler, caused by lack of airflow or blower motor is bad. Check all aspects of restricted airflow. Check the static pressure. 0.5 inch water column pressure is standard. Normally closed switch opens on rise of temperature. Automatically resets. Replace if open and will not close. So I just told you, if that limit switch is opening, you need to check your static pressure, right? What are you checking for in static pressure? Low static pressure, low airflow, dirty filters, dirty evaporator coils, blower wheels dirty, restricted return, supply air is not opened up enough, supply plenum is blocked off, collars are shut, dampers are shut, grills are shut. Just a list of things that reduce airflow. Blower motor set on the wrong speed. Okay? That's a list of things. If you check your static pressure, guys, I told y'all earlier, I don't know if it was on video or not, I think it was, but doing the right job and having the correct tools takes you a few more minutes on that job. One of the things I do not want you to do, I do not want to get a call, especially on new guys. I do not want to get a phone call from the customer saying he was here 10 minutes and he didn't do a damn thing while he was here. Because if I'm training you to do all this stuff properly, one of the things I'm training you to do is not only go over the entire heating system, but also go over the ductwork, look at your outdoor unit, put a little hose to the outdoor unit, and then spend the time with the customer and tell them everything that you checked.
You'll feel more comfortable if you are taking up more time.
Yeah, and bottom line is,
if you connect it with the customer, you'll feel at home.
And I will tell you something else that, man, I used to do this all the time when I worked for a company many years ago. And this is how I got a lot of my business. And I'm going to say, being in business for myself, learned how to do this working for somebody. So therefore, I ended up stealing a lot of customers because I did this when I worked for them as well. A customer wants to know that you, quote unquote, have their back. You are the guy they can rely on. The customer we're doing today, replacing an evaporator coil for them, okay? Well, they've been my customer for 16 years, okay? You don't think I know this customer? And look, they've had a lot of problems with their system because in their particular case, they have a foamed attic and it's caused plenty of refrigerant leaks in their attic on that unit upstairs. The one in the hall, never had a refrigerant leak. The one in the attic, constantly, okay? So we're replacing the evaporator coil today. Literally 16 years they've been my customer. I've been in their house so many times because of problems that not our problems, it's problems with the equipment that we have to fix. But because I've become friends with them, look, they call up, okay, I'm going over to your house and I'm going to be there about 2 o'clock. Is there anybody home? No, nobody's going to be there, but the key is in underneath the mat in the back. and my kids will be home in about 30, 40 minutes. She got 2 daughters. I'm gonna call them tender age kids, you know, I mean, 11, 12, I've been knowing them, shit, they're probably 22 years old now, so I've probably been knowing them since they're 4 and 5. So if the bus drops them off in front of their house and they're 2 little bitty kids, and there's stranger air conditioned man sitting inside their house, how many people will let you do that?
That ain't happening.
It ain't happening in my house. Well, you don't think I was friends with these people? You don't think they know me and trust me? That, okay, well, I'm not saying the name of the kids, but they'll be home in a little bit, and her mother actually lived 2 doors down, so she would come over and meet the kids, obviously, okay? But it was just go in my house and take care of whatever you need to take care of, I'm fine. So what I would do with customers when I worked for somebody, and I worked for them for like 8 years. So I want to build up a clientele working for somebody, because here's what it does for me. I go to your house and I say, hey Darnell, I checked over everything in your home. Here's what's happening on your home. Here's this, I recommend this, I recommend that. Hey, everything looks good. Tell you what, I know it's the first time I've been out to my house. I hope I did a good job for you. You know, I'm new with the company, and I would appreciate if I did a good job for you, that next time you have service, I appreciate it if you ask for me. Now, how is that going to fly over with the customer?
Well,
Are you ever going to get a call back from that customer that says, I don't want him back at my house? No.
they're gonna do just that.
Unless you did a shitty job over there and they go, no thank you, I don't think I'll bring you back. But if you do all the things I'm telling you to do as far as service wise and covering your ass on everything that you're doing,
You'll be sold after.
yeah, you become the number 1 guy they want. And then be personable with the people when you go there. And I used to look at it like this. I go to your house to go service your system. And this is just a difference in some people. I'm going to your house to service your system. You know what? You're not the company's customer, now you're mine.
Yes.
So I look at it like that, because if you tell me, or if you call back and you say it don't work, then I go, damn it, let me go check something else. And then I'll go back over there, I found it, I missed it the first time, and I'm honest with you, the whole 9 yards of it. What do people want?
Honesty.
They want honesty. If you mess up and you tell them, look, I messed up, I missed it, it's 100% my fault, I apologize for it, it ain't gonna cost you a dime, I missed it. I'm not gonna tell you anything else other than I missed it. I screwed up. I took care of it for you. I apologize. Bitch at me now for that. I took all your ammunition away. I'm not allowing you to bitch at me because I took full responsibility for it. Okay? You know? Hey, look, I'm not gonna say it, other than I didn't put a wire back on. I thought I did, I missed it. End of story. So, I'm gonna apologize to you. If I can do anything to make it up to you, I'll take care of it. Alright, you ain't got no problem with that customer, you know. But you're really not gonna miss all these things, and you're not gonna miss putting the wires back on, because you're not gonna leave. Because you're gonna check it before you leave. Okay? So you're gonna catch 99% of your own mistakes before you leave if you test the air conditioning, test the heating system again before you walk out the door. Because you pulled shit apart, you pulled wires off, you moved shit around, you hit float switches, you blew drain lines, you hosed the condenser, you may have pulled the disconnect out on the condenser outside. You did a whole bunch of shit. Now you're fixing to leave, but you didn't check everything you did. Did you put it back together? Dude, turn the air conditioner on before you leave, and turn the heater on before you leave, and make sure both of them run. Okay? If I can tell that to you 1,000,000 times, I will tell it to you 1,000,000 times. It will save you so much time and me aggravation. All right, number 9. That's just another rant. I ought to have just a video on rants. Huh? All right, fuse blocks. First, tighten the wires on all lugs. With fuses, you must pull them out and inspect. Are the ends discolored, purplish? Does the fuse paper seem crisp? and dry? Does the fuse box have burned wires? Does the pullout have melted plugs where the melted plugs where the screws are? Is the pullout broken in any way? So if everything is okay, nothing's burned, correct fuse sizes, everything is tight and secure. If it's burned, you have fuses that are burned, discolored, bad connections, wires are burned. Replace the disconnect box with a breaker box and obviously cut back the wires. If the fuse block is broken, replace it if it's like in 2 pieces, and then replace that fuse box with a disconnect box with a breaker. So this is an example of a bad breaker box, okay? So in this box here, you have a pullout. And I know you probably can't see it in there, but this particular one is discolored up inside of here. When I look at it, I can see it's rusted and discolored. When I look at this here, I can also see from the side of it, you can probably see this, it's discolored on here and it's burnt up inside of here, okay? This happens to be a piece of my fuse that was up inside of here, which is all burned up and in pieces, okay? So obviously this system did not run. And with that being said, I would bet you a dime to a dollar this is probably not off a disconnect box for a condenser, but probably an electric heat system. I'm saying probably, okay? Could be either one, but because it happens on both of them, obviously. So if you go to this specific unit and your fuse is still good inside of here, okay? And if you look at this, let me get it over there. It don't look bad, but the wires coming into it would be charred and burnt. And that all could be caused, all of this could be caused by this wire not being tight. That's why part of your PMA is to do what? Take this panel off of here, stick your screwdriver in there and tighten each one of those wires. Now what happens if your screwdriver touches the side right here? What's going to happen? It's going to short out. You're going to trip your breaker. Then you got to go reset the breaker or replace the fuse. So should you turn the power off to this before you do it? Yes. Okay? Anytime you stick a screwdriver in something, you know, kill your power is what you should be doing. Okay? Now, how many people do it?
No,
I'm not going there. All right? I'm just not going there. I can tell you a funny story though. I'm going to tell you a funny story real quick. I love my stories. I was checking a breaker in a electric heat system. So I needed to tighten my wires, right? That's part of my check. I stick my screwdriver in there to go tighten it. Of course, I didn't turn off my breaker, right? I didn't kill my power. I stick my screwdriver in there. And all of a sudden I hit the metal. Pow! It blows. What's your first reaction? Right? And then I open up my eyes, and for that split second, I went, I'm blind. And I went, wait, no, the power's off. And I started laughing, and the customer's like, you okay? And she hears me laughing. I'm like, yeah, I'm fine. I just blew a breaker. No problem. I'm going to go reset it. No big deal. But for that split second, I thought I was blind. I really did. I couldn't see shit. It was dark in there. That's a scary feeling, man. That is a scary feeling, man. Seriously.
I ain't gonna see no more.
Right. Man, when you got that flash of you're blind, that ain't no fun.
Your whole life passing.
Alright, so the smart thing I should have done was go kill the breaker, tighten the wires, and then put the breaker back on. That's the smart thing I should have done. Did I do it? No. I have a story for the rest of my life though. Alright, high voltage, tighten all lugs. Check volts, 208 to 240 volts. Check high voltage wires. Are they burned? Proper size wires with correct amps. See number 4, which we went over all of breaker sizes and wire sizes on number 4. For proper amps and wire sizes. OK means wire sizes, amps, condition of the wires are all OK, tightened all the lugs. Burn means wires are burned, could be bad connections, or wire size is wrong for the kW heat that is in the system. Check everything for proper size and amps and connections. I can't express that more and more and more and more. If you do an electric heat system, what is the number one thing you have got to check? Breaker sizes, wire sizes, heat, amps, burning shit. Okay? Not tripping breakers, burning shit. If I got 60 amps drawing into a 40 amp breaker, I don't have to worry about burning. It's going to trip the breaker. Okay? So if you get there and you have a tripped breaker, it's high amperage. Okay? As soon as you turn it on, somebody put a 15 kW heat system in and they forgot to disconnect 5 kW of the heat. So I'm going to say we sold a 15 kW heat strip on this particular air handler, whatever it is, and when we got there, we went, oh shit, it's only got a number 6 wire to it. So I'm going to disconnect 5 kW of the heat. And if I disconnect 5 kW of the heat, that means I'm literally going to pull a wire off of the actual heating elements themselves, and you can't actually make this run again unless you literally go take the wire and put it back on. How many people are going to go into the system and reconnect that wire back? Is the customer ever going to do it?
No.
How many customers you ever think you're going to go dig in the wiring of your heating elements?
None.
0. Everybody's scared of electricity. Yeah, make you blind. Right? So we'll disconnect that 5 kW heat. We'll just lay that wire up inside there. Well, you got 2 breakers. You got a 60 and a 30 amp breaker in there. Now you got to feed a number 6 wire into the other breaker. What's the other breaker literally feeding now?
Nothing.
The blower motor. That's all it's feeding.
Yeah.
So can I now take a number 6 wire, stick it in a breaker, take a number 10, and jump it over to the 30, and that system totally draws 42 amps? Can I do that? Yes, I can. It's only drawing 42 amps.
Yeah.
I've disconnected my 5 kW heat, but I have to make sure that I disconnected the 5 kW heat on the correct heating element. Right? I could literally pull that wire off of the breaker, and if I follow L1 around and I go, oh, okay, on this breaker right here, I see I have a blower motor to it and I have a 5 kW to it. If I literally pull L1 off of that breaker and I put some black tape on it, can't touch anything now, can that L1 ever come on? Or can that last heating element ever come on? And I pull the yellow wire off of it too, and I tape it up because the L1 goes around through it, comes back to L2 on my yellow, right? And I tape it up as well too. Can that heat strip ever get power and ever run? The answer is no. What if 10 kW heat is not enough heat for this specific house, and then later on we want to add 5 kW heat to it? Okay, all we got to do is run a number 10 wire over to it and then feed that extra breaker, take the tape of it off, put it back on, now I got 15 kW heat. Okay? What if the 10 kW heat doesn't warm my home enough? Can I lower my blower speed? Now we go back into that other wiring diagram that I did earlier and lowered my blower speed. You remember how I did that? Okay, we cut the black wire for the fan, brought it into the 9293 relay, came out of the normally closed switch of it, brought it back into the fan, that left it alone, put that relay on a W and a common, and then on the low fan, ended up tying that into the normally open switch to it, and then my low fan came on. Okay? So if I tell you how we came up with that fan switch and why we came up with that fan switch, I did that that must have been 15 years ago, 20 years ago or something that I came up with that, to put that fan switch on a air handler. We went to a job. Now the first one I did it to was over here in Marrero. And 3.5 ton system just was not heating the home properly. So I'm like, the air handler only uses 1 blower speed. Why does the air handler only use 1 blower speed, guys? Because a heating element, an electric heat system designed from the factory, blower motor size, the whole 9 yards of it, airflow across that heating element, is designed for cold weather conditions. Do we have cold weather conditions here?
No.
we have a couple weeks out of the year sometimes, right, that we need a heater, right? So, if you live in Chicago, where my son's living at now, he says it's starting to get cold out there already, I bet you can't have a 3-ton system with 10 kW heat out there. I bet it's 15 kW. So therefore, them running that blower speed on high speed with 15 kW is going to get your proper delta T. But running high speed here in the south, when you only need 10 kW and running it on high speed, your delta T is not proper. Does that make sense?
Yeah.
Higher the blower speed, the lower the delta T. Slow your blower speed down, the higher the delta T. Remember, when you check your heating system, I want you to check your delta T to see what your heating system should be between 35 basically and 55 is where your delta T should be. Remember, I also talked to you about checking your delta T by changing your blower speed to the cooling speed to get your proper delta T on the fan speed that is being used for cooling, put in the heat mode. Then you let that system run for quite a while after you have overheated your heating elements and heated up the plenum and the chamber and the whole 9 yards of it. And then from there, you end up testing your delta T to get your once you get your delta T, you go to Coburn's Connect, go into the app for calculators, and you do your calculation to see how many CFMs that system is drawing or utilizing for cooling mode. Now you have to go check to see what condenser you have, what tonnage it is, how many CFMs you have, and is that CFM correct for that specific tonnage, and do you have to increase or decrease the blower speed of that particular unit running in cooling mode. Then you turn it back into the heating mode and put it on the lower speed where you originally had it designed to, and then you check your delta T in the heating mode. The delta T in the heating mode should be between 35 and 55. Your delta T with the fan in the cooling speed is not going to be probably between 35 and 55, maybe closer to 30. Okay, but it's not going to be 55. Okay, if you got 55, you got dirty evaporator coil. All right. So again, please go over these things that I am telling you, because I went over this exact same thing on the furnace check on the other. The last thing is the other we went through, and we went through the blower chart, and that's where I drew it on the board right there on the furnace check. So our high voltage that we're looking at on number 10. Okay, wire sizes, amperage, condition of the wire, all okay, tightened all lugs. Burn, wires that burn could be bad connections, or wire size is wrong for the kW heat that is in the system. Check everything for proper size and amps and connection. C is miswired, wrong size wires for kW heat. Refer to number 4 for proper wire sizes. If you keep this book with you, you should have no questions on what wire size goes to what system. Low voltage, check the connections and make sure the system is set up properly for how it is designed. Example, 2-stage heat, W1, W2. Are they jumped? Do you have a 2-stage thermostat? So if W1 and W2 is jumped off and you have a 2-stage thermostat, are you utilizing the efficiency of that air handler? The answer is no, you're not. Because if you hook W1 and W2 separately, and you got a 15 kW heat system, then it'll turn on 10 kW and turn on 5 for your secondary heat. If you have a W1, W2, and you have a 10 kW heat system, you just use W1, W2 together, because 2-stage heating on 10 kW system doesn't do you any good, okay? If it's 20 kW, you can draw 10 and 10 on W1, W2. Makes more sense. Let's see, 2-stage thermostat. Is this a heat pump? Does the emergency heat work? So if you're checking your low voltage, like what the one of the guys was doing today, checking a heat pump. Well, when you check a heat pump, what happens? You got to turn the heater on. So on a heat pump, in case you guys do not know this, especially you new guys, When you turn a heat pump on, what does it energize?
The reversing valve.
It energizes the reversing valve. So, if your low voltage wires are R, Y, W, G, O/B, we'll leave it at that and comment, okay? When you turn a heat pump on in the cooling mode, your thermostat goes connection between here, connection between here, Y and G, okay? On some systems, depending upon that particular brand name and model of that system, sometimes it also, in the cooling mode, also energizes OB. And OB will tell you if it's a programmable thermostat, think, maybe wrong. I think O energizes in the heating mode and B energizes in the cooling mode. So if B energizes in the cooling mode and you have a heat pump, okay, you got to turn that air conditioning system on and you got to decide, do you set that programmable thermostat and the selection of OB in your setup, which one do you put it on, O or B? Well, hell, if you don't know which one turns which one on,
You don't know what
go turn the air conditioning system on and see if your heater runs. If that's the case, then go see what this is set at and put it to the other one. It won't take long for you to figure this out. It's a 50-50 shot, okay? When you turn your heater on now, we're going to take this off of here for a second. When you turn your heater on, what is energized? And this is most of them. When you turn your heater on, R brings over to W. I'm sorry, I'm wrong again. Okay. When I turn my heater on a heat pump, and it's energizing in the heating mode of the solenoid valve, okay? Then this is going to energize Y again on a heat pump, and it's going to energize the O. In first stage heating on a heat pump, Y is energized because your condenser's running. O is energized because you're energizing the reversing valve, which is now turning it into the heating mode, because when it, in this particular case, when it's de-energized, it's in air conditioning mode. In certain brand names, it is vice versa. That's why you got to figure it out, okay? So this is first stage heating on a heat pump. Now, I got a 36,000 BTU air conditioning system. How many BTUs will the heat pump put out? Close to the same. Okay. What temperature air does the heat pump put out? What should be my delta T? It's not like a heating element. It's an air conditioner running in reverse. It's not gas furnaces. A gas furnace. So a gas furnace delta T will normally push out in the neighborhood of about a 50-degree delta T, normally. An electric heat system will normally between, I'm going to say 30 and 45, maybe at the most, usually. A heat pump you may get 20. All right, here's my problem now, guys. Here's my house. I have 10-foot ceilings. Here's me. I am at 5'7". I mean 6'3", I'm sorry. Just the board's really short, that's all. Alright, here's my grill. All the way up here. Alright, I got airflow coming out of my grill. My house is 65 degrees. I turned my heater on because I want to kill the chill. My delta T on a heat pump is 20 degrees. What temperature is my air? Okay, let's stretch it. It's 25 degrees. It's 90 coming out. Who cares, right? What temperature am I?
65 degrees.
Nope. What
85?
temperature is the human body?
Oh.
97 degrees. Okay? 97.8. So here I am at 97 degrees right here. I got 10 foot. So I got a little over 4 feet here. Right here is all 65 degrees, right? I got 85 and call it 90 degrees coming out of my vent. So let's call it 85 for argument's sake. We'll call it 90. Let's give it a little more. Let's say it's really working good. So I got 90 degrees coming out of my vent. So I'm going to go 85, 80, 75, 70. Hell, I got 70 degree air blowing on me. Am I happy? Am I heating the house?
No.
Not by much.
Yes, I am heating the house.
Just
The top
top
part,
down.
but not
What happens to heat?
Heat rise.
rises.
So heat rises. I have an above ground house. Where's my coal coming from?
Underneath the house, the floor.
Where's my air infiltration coming from on an old New Orleans house?
Cracks in the floor, cracks in the windows.
You ever seen a floor on an old New Orleans house, like just after it was foamed? And they got foam sticking out all over the place on the floor? Because it wasn't sealed properly to begin with. Because the old New Orleans houses, the way they were built, literally you got a 2x12 underneath there, and then your hardwood floor is right on top of it. There's no subfloor, there's no vapor barriers, there's no nothing. There's your floor right on top of it. That's the way they were built back then. Is that heat pump efficient for my home?
No.
Not in that home, it's not. Okay, I can't get gas to that home. Is it efficient for that home? I can't get gas.
Electric heat. That's not going to be efficient.
So I have two choices. I have electric heat or I have a heat pump. Which if I have a heat pump, don't I have electric heat as well?
Yeah.
Yeah.
How many days out of the year do we run our heating system?
About 2 weeks, like you said.
Okay. So out of the 2 cold weeks out of the year where my heat pump's really not doing much good,
Use the emergency heat.
you use emergency heat, which is electric heat anyway.
Mm-hmm.
So I have to have an electric heat system regardless, because I can't, in this case, I can't provide gas to my house or propane or whatever. I just can't do it, okay? So, am I ever really gonna get warm with that heat pump because my floors are always so cold and it's 10 feet ceilings? Am I ever really gonna get warm in that house? The answer to the question is no. Not really warm because there's such a draft in that old New Orleans house, okay? But if it's a slab house and fairly insulated, the answer is yes, I'm gonna get warm. Okay? I'm gonna get warm. I don't care if it's 10-foot ceilings because I am heating the air in my house to 90 degrees, okay? And as I continue to heat the air to 90, this is gonna go from 65 to 70. Well, I don't want it no hotter than 70 anyway, running the heater. I just need it 5 more degrees to make me comfortable. I'm good. How many amps does this 3-ton heat pump draw in heat pump mode? So, you're checking your amperage on your compressor, right? I'm just going to call it 12 amps. Right, wrong, indifference, it don't matter. I'm just using the number. It's 12 amps, okay? How many amps does an electric heating element draw for a 3-ton system? What kW would you put that?
10,
Which is how many amps?
60, me 42.
No, I'm thinking throw something at you. 42 amps. If I can heat my home with 12 amps instead of 42, am I more efficient?
Yes.
Will I be able to heat my home in the south to the heat pump?
Yes.
No.
Yeah, absolutely. Absolutely. Why not? We have 2 weeks of cold weather. Other than that, we basically kill and chill in the house. Right? It's 50 outside. We only want it 70 in the house. The insulation is going to hold the heat in anyway. You have a natural heat load, cooking, washing clothes, all that kind of stuff. You're naturally providing heat in the house just naturally, right?
Mm-hmm.
Okay. Electronics are running, all that kind of stuff, right? So you just gotta heat the home. If you got a slab house, you're good. You got an above ground New Orleans house with 12-foot ceilings, no, you need gas heat. And you need it on high fan. And you need maybe 100,000 BTU heater on that 3-ton furnace, not a 75. Because you got 14-foot ceilings and you need that airflow blowing down. Or you need a floor furnace, right? And get waffle feet. An electric heat system on the old New Orleans houses is gonna run that energy bill skyrocket. Okay? So, when you walk into that house, guys, here's another thing. You walk into that house and you're doing an electric heat system check on that house. I just got finished giving you several different houses. And you know what that customer told you when you walked in there? This house is always cold. Is that heating system really running? Yes, ma'am, sure is. Everything running on it fine. Well, how do I get my house warmer? Well, man, everything's working fine on it. There's nothing really to do on it. It's drawing everything it can. What are you literally supposed to tell the customer? It's drawing all the amperage you can, right? And nothing else you can do as far as heating wise. You got a 3-ton system, you got 10 kW heat, it's doing it. What is the customer asking you to do? Warm her home. So what do you need to do? You need to understand building science. This job is not just heating and air conditioning. It's building science. She's asking you as an air conditioned person, as somebody who is supposed to be able to
Heat and cool her home.
heat and cool her house properly, to tell her what she needs to do to heat and cool her house properly. It's an above ground house. Ma'am, what you might want to consider is have your floors foamed. Y'all do that? No, ma'am, we don't. Just look up somebody who does foam insulation on your floors and have your floors shot, and that'll stop the air infiltration. Ma'am, you may want to try magnetite on your windows to stop all the air infiltration through your windows. Okay? You know, we also do blower door tests. A blower door test, we actually take a blower and we put it on we open your door up and we put a big screen on it, we put a blower in there, we hook computers to it, and then we suck all the air out of your house. We close all your windows, all your doors, and we suck all the air out of your house because your house is cold because it's drafty. I know, it's an old New Orleans house, I know. So let's go and let's seal your house now. Let's look to find out where all your air loss is in your entire home. So I've been in these old New Orleans houses, you've seen them with pocket doors. Well, if you look inside there in the wall, you can see underneath the house, can't you?
Yeah.
You can, that's no bullshit. You can see underneath the house, okay, a pocket door. So you do a blower door test and you walk through the house and there's air coming through those pocket doors like crazy. Every outlet, the air boom, sucking out of the air. Every window, air coming out of it. And you go, man, there's nothing I can do for you. Yes, there is. You can help seal the house. There are things that we can do. We can put over the outlets, okay? You can recommend them sealing the floors and stopping air infiltration. But you know what you just did? You educated that customer on how a house actually works and how the house is actually built. So most customers most people in a general sense don't understand building science. We take an old New Orleans house that's 150 years old and then we go insulate it, foam it, change the design of it, put an air conditioning system in it, try to seal it, try to change the windows, but the building science of that house was made for balloon framing. No air condition, just a fan. That's the way the house was made to keep cool. A lot of us have, old grandma that lived in that house. My grandmother, okay, lived in that house. The house would get hot. She never had central air. I mean,
Attic fan.
I'm trying to remember if we had even any window units back then. Grandma's house didn't have window units back then.
Mine didn't.
We just came in the wintertime, and I remember we came in the wintertime, and this old house is like an old built New Orleans house, right? No insulation anywhere in the entire house. And it had floor furnace, not floor furnaces, space heaters. So the only place that was actually warm in that entire house was like 6 inches in front of the space heater. And literally that was it, okay? So as little kids, you got a big old room and no insulation anywhere, and it's 20 degrees outside. You know, you got 4 little kids at between, 4 and say 10 years old or whatever. So all 4 of us, the only way you would stay warm in that room, because the whole room with that space heater running did not get warm, okay? Is Grandma used to make her own blankets. And those blankets that Grandma would make were heavy blankets, right? Everybody, I love them blankets, man. I want Grandma back. So we'd all climb into bed, had a big king size bed with 4 little kids, everybody climbing there, and they would stack 3 and 4 homemade blankets on top of you. Well, you get in the position that you need to be in because you ain't moving after that. But in the middle of the night, you wake up and your face is kind of frozen, right? You get out the bed, and the only place that's warm in the whole house is next to the space heater.
The stove.
Yeah. Yeah, think about it. We ran stoves, we ran space heaters in order to warm the house, which is putting carbon dioxide in the house. Why do we not die? Because the house is so leaky. It's so leaky, okay, that air is just coming into the house. It's just mixing with all that carbon dioxide, and we're good. Tasted fine, All right, there's another rant. I gotta stop the rants, man. These videos wouldn't be so long without rants. Where are we at now, man? Low voltage. We just did low voltage, didn't we?
Yep.
All right, now we're on heat anticipators. What is a heat anticipator, guys? Which we went over in the last video. Heat anticipator on an electric heat system, same thing it does for a gas heating system. On a gas heating system, you set the heat anticipator by the amperage of the gas valve. With an electric heat system, you're actually setting the heat anticipator by the amperage of the heat sequencer. So you have to wait till all heat sequencers are pulled in to set the heat anticipator. A heat anticipator, for those of you who haven't watched the gas furnace video, is an old manual thermostat with the mercury bulb on it. And that old thermostat has got a heat anticipator in the inside or the front part of that thermostat. So here's your old mercury bulb thermostat with a little lever on it right here, and you move it up and down and change the temperature on it. You pull the cover of that thermostat off, and you will see inside there a little mercury bulb up at the top, and it's got what's called a helix coil up inside there. Then inside there they got a little round disc, I'll call it, inside there, and in that little disc, I'm going to make that disc bigger. In that disc, there is a metal wire that runs around like this and stops here and stops here. Inside there, there is an arrow. Now notice that arrow does not touch this side, but it does touch this side over here, okay? So I'm going to call this 0.04 right here, 0.03 right here, 0.02, 0.01, and it comes around with other numbers here. You take this part of your thermostat off, and you're left over with the bottom of your thermostat called the base of your thermostat, and you have R, W, C, G, Y, because you're not having 2-stage with this thermostat. Then you take your amp probe and you take a low voltage wire and you go from R to W and you put your amp probe on there, and you are going to read the amperage draw between R and W. When you read the amperage draw between R and W, you have to wait till all heat sequencers are energized, and then whatever amperage it comes on your meter here, on your amp probe, is what you point this to. So if it says 0.09 and then 8 and then 7 and then at the end of it it's 0.04, you point it to 0.04, and the heat anticipator will then tell that thermostat when to turn the heater on and when to turn it off. It will not turn on and off by temperature. it turns on and off by the heat anticipator. So if you set this wrong, it will not come on and off at the right temperature. Next thing, if you short that thermostat in any kind of way, you will break this wire. When you break that wire, your heater will not come on anymore. You have to replace the thermostat. Next thing, I'm going to be a real dumbass, and I'm going to say, you know what, I'm going to screw these people over. I'm going to take this little dial right here, and I'm going to turn this little dial, and I'm going to make it now face like this. Now you notice that little arrow is not touching the wire anymore. If I turn that dial, that little arrow does not touch that metal anymore, a wire around it, that heater will not come on anymore. So now, just did your spring check and clean, right? You need me again for the winter time, don't you? That's pretty shitty, but I've seen that done a bunch of times. That's pretty shitty, but the heater won't run until I go take the dial and move it back again. I've seen it done many times. That's why people get bad names, man. I shouldn't even showed you how to do that. Last one, 13. Wire sizes. Write down what size is in the air handler and disconnect boxes. You have to be aware of the wire sizes. If you don't know, get a piece of each wire and have it with you to gauge the wire. So in the classroom here, we actually have some pieces of wire. So this is the number 6 wire. This is the number 8 wire, and if you literally look at the physical size difference of the two wires, they're not a huge difference apart, but they are some, okay? Then you're going to have a number 10 wire, and you're going to have a number 12 wire, and you're going to have a number 14 wire. Now, these are not color-coded wires. Can I have some white wire that's going to be number 10? The answer is yes. I can have orange wire number 10. I can have yellow wire this one. I can have white wire that one. It's just different type of wires, all it is, and that's why it's called color-coded for different things.
The only thing that can help you out is in the Romex. If it's in a
Yeah,
color like that.
yeah. But you can also read what size wire it is on here, but you actually have to find a piece of wire where it's actually written on, and this is not one of them, okay? So neither is the 8 wire. But it does have something written on the number 14 wire here, but it doesn't have it as a number 14. So, and neither, well, 10 is written on here. They actually do have a number 10 on that one. So it is written on the wire, but if you have a long enough piece of that wire, you can actually read what size wire it is. But guys, your wire sizes, I can't stress enough. If you're checking electric heat system, wire size, wire size, wire size, wire size, breaker sizes, fuse sizes, how many amps are you drawing? Are you drawing too many amps? Did you check all your electrical connections? Did you check for heating? Did you check for burning of it? If you have a bad disconnect, like that disconnect I just showed you over there, I'm going to tell you something that if you do not do this, you will go back out to these customers' houses again very soon if you do not do what I'm fixing to tell you to do. That disconnect box for that electric air handler right there that we showed was burned up. I am telling you to go to the main electrical panel. Take the cover off the main electrical panel, find the breaker for that particular furnace, and then turn the breaker off and tighten the wires on that breaker too. Because a lot of times with electricity, the weakest point burns first. I have taken and replaced disconnect boxes in the attic that were burned up but never went to the main electrical panel. Next day, guess what's a strong connection now? Everything I just put in, right? It's all strong, it's all solid. Guess what burns tomorrow?
Breaker.
The breaker in the main panel, because it's now the weak connection. And I call up and they go, "You caused that because it wasn't like that yesterday." And I go, "No, I didn't cause it. I just didn't check it."
Same difference.
No, it's not
No,
the same
but if
difference.
you
I
had-
just didn't check it.
But
In their head.
in their head.
Now, I can get out of that. Let me tell you how I can get out of that. I'm not licensed to go on the main electrical panel now. You have to call an electrician to take care of that. I can handle your disconnect boxes from here. but I'm not licensed to go in an electrical panel, so that's nothing that I can go into. I'm not lying with that, but can I go into it? Yeah. And can I change a breaker in it? Yeah. Okay? I just didn't do it.
Okay,
Okay? So,
but that's not what you want us, you want us to,
if you got
I
burnt
mean-
wires, I'm telling you to go in the main electrical panel and tighten those wires.
yeah, I'm saying
Because
that's
burnt
part of.
wires always find the weakest connection.
Okay.
I have went into breakers, guys, that in the main panel, in the disconnect boxes that are burnt up, and I go, let me go check the main panel, let me just go verify. And I go into the main panel and I take the cover off, and I go to the breaker and I start hearing as I'm turning it, and I'm going, oh shit, that breaker's cracking all up.
Mhm.
So I use my screwdriver and I pop the breaker out, and I go to the inside of the breaker, and that thing's just charred up and chewed up, and the breaker itself, where it's connected into, is all chewed up, and I can't put that breaker back in that one spot now because it's all chewed up. Now think about this. I got a main electrical panel. I got a 60 amp breaker, call it 10 kW heat. I got one 60 amp breaker I'm dealing with here, and now that breaker's all chewed up. I got to replace that breaker. If I take that breaker and I see that the terminal bar that I'm plugging that breaker into is literally all chewed up and just like beat down, like it's been eaten by a dinosaur or something, whatever, I don't know. If I put a new breaker in there, is it going to do the same thing?
Yeah,
Yeah, it's a bad connection. So what do I need to do?
go to another location on that.
I dipped it in the, I forgot the name of it, the chemical?
No.
The thing it's gonna do.
The reason it's got a bad connection on it is because it's burnt and it charred, and when it charred, it's no longer a smooth piece of metal. So if there's one little piece of that metal that's sticking out like that, when I go stick it back in, what is my only connection? Here, not smooth going in there. It's got that one little piece sticking out, and it's only on that one little piece. It's gonna give you a bad connection again. Can you sand it down? No, it's got 240 volts to it. You can't do that either. But you know what you can do? See if there's another open space and move the breaker to another open space. Tell you something else you can do. What draws the most amperage in that house? Probably that electric heating element. So I may take 2 or 3 breakers that are above it or below it, and I may take those and move them up or move them down and take another space.
Take another bus.
Yep. So if the power that's going feeding the stereo system and that kind of stuff, it's not drawing hardly any amps and hardly ever draws any amps, and it's a 15 amp breaker and normally draws 3 amps. Is that breaker ever going to trip now?
No.
No. Probably not. I put my new one in a nice clean space. You know why? Because I don't want to come back up. I don't want to get a free service call. I want to make sure that when I do my job, I'm going out, and then I will tell the customer, I moved the breaker to a new space. You need to call an electrician and have him come look at your electrical panel. Because I just moved 3 breakers down or 2 breakers down, and I took a different space so I can put my breaker in so that you can have heat tonight. Because I can't put it back in that same space. Okay, but you need to call an electrician. On my paperwork, move breakers down, use a different space in the main electrical panel. Customer needs to call an electrician, have electrician check out main electrical panel. There you go, cover my ass. But I'm not getting another call back out because I put my breaker in the right spot now. Okay? All right, that concludes the electric heat system check. This is for electric heater check portion of the PMA. Know your wire sizes, amperage, breakers, fuse sizes, delta T. All these things are extremely important. To make sure you are not burning wires and the customer is safe, the customer is depending on you to check all the wire sizes, make sure all the electrical in the heating system is safe for their family. Your job is to check all the safety features for the electric heating system. Do not shortcut these steps. These could cause fire and possible death. As we end with that portion of it, again, I started it out with that same thing and I'm ending it with the same thing, right? That portion of checking an electric heat system is the most important of causing death, okay? Causing fire and burning a house down. We all hear about when we get into the heating season, when you get into hurricane season, and people run generators and die from carbon monoxide poisoning from generators, right? We all hear in the heating season, people die of carbon monoxide poison from their heaters, bad heating systems. We hear of, during the winter time, most of the time, of electrical fires, and it's mainly because of too much high amperage draw and people don't get their heating systems checked like they get their air conditioning systems checked. So the worst home you go into, guys, the worst, not home, but the worst community, I will call it. The poorer communities will have their systems checked less. End of story, okay? And it's just an economic feature of it. So the economic feature of it, and you know it's never checked, then do your due diligence when you go there and check the entire system properly and make sure that no houses are being burnt down on your watch, not on something that you went and checked. All right? I hope I made myself perfectly clear on the safety aspect of checking all these systems, guys. I hope you can watch these videos over and over and over and use the information that's in these things so that you can actually become a really good technician. And I'm telling you, the difference between a good technician and a shitty technician is being thorough, having the correct tools and knowing how to use the tools. If I can just get anybody to follow my direction, follow my guidance and say, buy the tools that you need to use for checking carbon monoxide. Buy the tools, your electrical meters, to make sure that you're understanding your amperage draw and voltages. Buy your tools for checking static pressure and gas pressure. Buy your tools for checking leaks, refrigerant leaks on the system. Buy your proper gauges so that you understand superheat and subcooling, and buy your laser for your delta T's. Get a sling psychrometer and make sure that you understand what your wet bulb temperature is. Get a wheel puller to where you can pull the wheels off of blower wheels, okay, off of blower motors, so that that blower wheel slides right off of that. You know, it's going to cost you a couple $1,000s total overall. Maybe not, yeah, a couple thousand total and all that stuff. But damn, you can pay for it in no time if you actually just use them. You know how many duct systems you could sell? Literally, how many duct systems you could sell checking static pressure in every damn duct system you go to? Like crazy. Like crazy. If you go check every duct system that you actually go to, and you go take a picture. Now let's just say on a regular basis, I'm just going to say 80 to 85% of the houses you go to are not new duct systems. Just call it that for argument's sake, okay? In a year's time, if you did this one thing in a year's time, how many times would you sell new duct systems if you did this one thing?
Take a picture.
I don't care if it's a vertical system or a horizontal system. If you understand how to take the cap of a plenum off of that system, you don't have to take the whole cap off. You can literally take a corner of the cap off, okay? Taking a screwdriver and a hammer and literally pop on the corner of it if it's not screwed and glued and airlocked and the whole 9 yards of it. If it's just on there, you can literally pop it right off to where just that one corner of the plenum comes off to where you can stick your phone in there, take a picture of the supply plenum, and you will take a picture of plenty mold up inside of that air hammer or that supply plenum, excuse me. You take that picture down to the customer, and if you do this time and time and time again, this is what you are going to see inside that supply plenum. And this is the mold and the mildew and the bacteria and crap and shit and dirt and all that kind of stuff up inside that supply plenum. This is what's growing inside your air conditioning system, and this is what you breathe on a daily basis. Ma'am, I just wanted to make sure that you understood that, you know, I know your duct system up there is, you know, probably as old as the house, but I wanted you to understand what is actually in your duct system before I leave today. And I took a picture of it. And it's pretty disgusting. So this is actually your duct system right here. This is literally a picture of inside your duct system. This is what you're breathing on a regular basis. And I just want to make this recommendation to you. Now, how all this figured out before you actually bring it to the customer? I've counted your ducts. You got 10 ducts up there. I've called my boss, and I gave them a rundown of what it would take in order to possibly replace your ductwork. And in order to replace all your ducts, your supply plenum, and get all this mold and mildew out of your system so that you can literally have a healthier home, and then put what we call a Remy halo inside that duct system so that we kill all the mold spores and bacteria and airborne contaminants and viruses in a duct system, and 24/7 sanitize that duct system. You're looking at right at $4,300 for the Remy halo and replacing that ductwork with flexible duct. We do have payment plans if that's of any interest to you. Is that something you want us to go ahead and do? Because this is what your duct system looks like right now. How many will you sell?
You sell everything. 80-90% of them.
What's the second most important thing I told you need to do? Presentation. Presentation. Now, you know why I took this picture? You know why I have it on here? You know how many times I've just done that? You know how many times I have sold new duct systems and I go, you ever seen the inside of a duct system? And I go, not only do I have one on here, I can show you, and this is our new supply plenum treated with Foster's 4020. It's an antibacterial paint that helps stop mold growth inside the system. Our new supply plenum we put in will be treated with Foster's 4020. It's an antibacterial paint that helps stop mold growth inside your system so that you do not grow all this mold again. Plus, we're going to put a UV light inside that supply plenum, and it's not going to allow all the mold to grow inside there. How many duct systems can you sell in an entire year's time? And literally, what tool did you use?
Photographs.
You used your phone.
And maybe a screwdriver.
And maybe a screwdriver and a hammer. Okay, and you know what else you might have used? You might have used a tie strap for taking a duct off, because, okay, that plenum is sealed up pretty damn tight. Okay, I'm going to go ahead and take some wire cutters or whatever. I'm going to go over there and I'm going to snip the one of the ducts off, and I'm going to snip the duct strap, and I'm going to pull it off. I'm going to stick my phone in there. I'm going to take a picture of the plenum, and I'll take it both ways because I want to find the most disgusting part of it, right?
Mm-hmm.
Take a couple pictures of it inside there, and I got 2 duct straps with me. Pull them out of my deal here, put it right back on, seal that duct right back up. It literally cost me 44 cents. Each duct strap cost me 22 cents. That cost me 44 cents for you to take that picture. I will take that loss if you bring that picture to the customer and say, ma'am, this is inside your supply plenum. Did you want to keep this in there, or would you like the price to go ahead and get all that duct system out of your inside there? Okay. If you, man, y'all plan on staying here, or y'all gonna be moving anytime soon? I mean, is this your forever home at this point? I mean, I see you're gonna have a little one coming along, or I see a couple little ones around. I don't know how much indoor air quality means to you, but I'll show you a couple pictures. This is what's in your duct system. Now wait till my husband gets home. Can you send me those pictures? Right? Now, if I told your wife that, and you came home from work and I show her all that and I send her the pictures, what's she gonna tell you when you get home?
Are we spending money?
You spend the money?
She's gonna tell you what you're
Is she gonna give you much
before
choice?
No.
She ain't giving you much choice most of the time. Okay? And guys, did I lie to her?
you leave. No. Did
You know what I did?
Tell her the truth.
I'm just a thorough technician. That's what makes you a good technician. It's not how smart you are. It's not being able to rattle all this shit off the top of my head for all these years. Yeah, of course you learn that over 30 years, but what makes you a good technician is that you don't shortcut that customer. And you do an entire 51-point checklist. That's what makes you a good technician. You want to be a good technician, you want to learn how to make money. Do it the right way. Go check every little thing on here and don't shortcut yourself. I had a technician who used to work for me many years ago, guys. And this is literally when I worked out of my house. That's how long ago it was, okay? And he came to me, he used to do warehouse work, okay? So I needed a helper because it was just me in the field. That was it. I had nobody else, just me and him. And he goes, man, he says, I'd like to learn a trade. He said, I'd like to learn air conditioning. And he goes, I don't know anything. I said, I'll tell you what I'll do. Seemed like a really nice guy, man. And had 3 kids. He goes, I'm just looking to support my family, man, you know? I'm like, all right. So tell you what I will do for you. I will teach you air conditioning if you just do what I ask you to do. Don't complain about it. Don't bitch. Don't moan, groan. Just do what I ask you to do, and I don't care what we have to do. It's just, that's the job. Just, that's my, trade-off to you. Now, at that time, I had probably 10 rental properties at that time. So guess who was doing all the maintenance work on it?
You.
Guess me. Guess who was painting it? Guess who was painting every time somebody moved out? Guess who was going to fix toilets, replace toilets, run plumbing, run electrical, cut the grass, fix the roof, fix the windows, and anything, and put carpet in, and put floors in. Guess who was doing all that at 10 o'clock, 11 o'clock, 12 o'clock at night, 2 o'clock in the morning? Me. Guess who was with me?
Your helper.
My helper. I was paying. So in return, he just did what I asked him to do, and he didn't complain about it. Because every once in a while, he's like, man, he goes, all right, let's go. It needs to be done. It's just me and him. It's either he does it or I do it, and I got to go run the service call, so I got to go set him up and go, here, go do it. I'll be back in just a little bit. And I'll come back and help him finish whatever we're doing. So in return, I taught him air conditioning. He got the opportunity to ride with me on a daily basis. So whatever I did today, he did today. He became a very good technician. And why he became a very good technician, because I kept stressing this one point to him. Do not shortcut yourself. Do not shortcut yourself. When you shortcut yourself, you will go to that customer's house and you will go, I don't feel like taking that disconnect box apart. I don't feel like going in the attic. I don't feel like going blow the drain line. I'm just gonna write on here that I did it. And blower wheel. Turn the meter on, it works. And a lot.
How many times that kind of stuff get you called back?
Most of the time.
Okay.
Okay? So I preached and I preached and I preached and I preached to this guy. Just don't shortcut the customer and just do all the things that I asked you to do. So to his credit, I give him credit. I stuck it in his head he had to go look at everything, all right? So he worked for me for quite a few years, and right at the time, Hurricane Katrina came, all right? I literally, this is how much I like this guy. I still own the house today. I literally bought a house in Lafitte, and I bought it for him in order for him to buy the house from me so he would have a place to live with his kids. That's how much I like this guy, okay? Katrina comes. Now, he's raising 3 little girls by himself. No, 1 little girl, 2 little boys by himself. And his grandmother's helping him. Katrina comes, wipes out, he moves to Tennessee. He calls me up a few months later and he's like, man, he says, I got a job out here, and that's where his family's from. And he says, they're paying me $15 an hour, and he says, and I'm not allowed to sell anything. He says, so I went to the boss and I'm like, man, I can sell a heart start kit, a time delay, a this, a that, a this, a that, a this, a that, and raise the revenue of the company. And here's how I can sell it without screwing people over. If they want it, they want it. They don't, they don't. I'm just trying to enhance the customer's units. And he goes, and if I sell it, say for $200, hey, pay me $20 of it. You have the $180. I just want a commission. That's all I want, They would not allow him to sell anything. All he could make was $15 an hour, 40 hours a week, and that was it.
That's dumb.
Sell.
Yeah.
So when he moved back here, he was back in the mode of, you know, what he was doing. But he became a very good technician. Now he screwed me over a whole bunch of other ways and ended up getting rid of him out of my life. But anyway,
But when he was good.
but
he
the
was
guy
good.
became a very good technician, and because he was very thorough. And that's all it takes, guys. That is literally all it takes. I've told you about Tremaine. I love Tremaine. Good dude, just good family man guy. He worked for me for 4 years until just recently went in business for himself. I don't think he was ready to go in business for himself because he didn't have all his ducks in a row, but to his credit, he worked for a apartment complex, you know, working the same 2-ton system over and over and over and over and over and over and over. And when he came to apply for a job, I basically told him, after asking him a bunch of questions, talking to him a little while, I'm like, dude, you don't know your head from your ass about air conditioning. And then after we continued, you know, with everything, he's like, you know, you're right. I don't remember all the stuff I tried to learn in school because I never utilized it anymore. I'm just working on 2-ton systems, 2-ton systems, 2-ton systems, and I'm never challenged. So I gave him all the videos, and all he did was he just watch video after video after video after video after video until it gets stuck in his head. I told him the same thing. Don't shortcut the customer. If you want to learn how to become a good technician, you can't shortcut the customer. You have to do everything on the video. You have to do everything on the invoice. So to his credit, when I tell him to do something, or if I tell him to go buy this, that, and the other thing, that type of tool, he'd call me up one day and he's like, my head pressure is this, my suction pressure is that, my superheat's this, my subcooling is that, my static pressure is this. I said, your static pressure? He goes, you told me I need a manometer to check static pressure if I really want to know what CFM that system's running. I'm like, yeah, that's what I told you. He goes, well, that's what I want to buy. He says, now, what do you think's wrong with it? So he would tell me what he would think is wrong with it, and I would give him what my thought process was on that particular deal. But to his credit, he became a pretty thorough technician, and it's hard to be thorough in this business. And I'm going to say it's hard to be thorough in this business, and this is the reason why. Because we work 60 hours a week, 70 hours a week. It's hot in that goddamn attic. You're in tight places. You're tired, you're hungry, you're sweating your ass off, you're aggravated. You're ready to go home. It's easy to take a shortcut. Don't do it. I'm just telling you, don't do it. You want to become a good technician, then become a good technician. Do what you're supposed to do. Don't shortcut it. Every time I didn't want to go check a capacitor, seemed like every time I didn't feel like going check the capacitor, and I go, no, shit, go check it. God damn it, you know, don't shortcut the customer. Go check it, and I go back there and check it. It's reading 32. It's a 45. Okay, sorry, you need a new capacitor, and I'd sell a capacitor. I didn't feel like going check my pressures because when I got there, it's 9 o'clock at night, and I gotta blow the drain line. I don't feel like going check the pressures on the system because it's 9 o'clock at night, and I'm tired. I'm ready to go home. I've been working since 7 o'clock this morning, and it's hot as some bitch. I'm ready to go home. I blew your drain line. The float switch was kicked out. Do I feel like going check your pressures outside? No, I don't. What I'm going to do? I'm bringing my gauges back here. I'm going to check your pressures, and I go, sir, you're low on refrigerant. You need to add refrigerant to the system, but you know what? Your system's 15 years old, and I'll sell you a new unit. So now I made $10,000 off of go and check my pressures because I didn't shortcut myself. I didn't shortcut the customer. I can't tell you how many times that has happened to me, guys. Because I get tired. I don't want to do it, you know? And that's what's going to happen to you. The more you get out there, and I'm telling you over and over and over and over and over again, starting out in this business, do not shortcut yourself. Don't shortcut the customer. Do everything that you need on here. Take pictures of everything that you do and back up everything that you say. If you got a picture that you got a number 6 wires, 10 kW heat, 42 amps, let your picture show it. And nobody can dispute you. Okay? I used to love when a customer would say, well, I had cousin Joe come and look at this system and he said blah, 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 it ain't low on refrigerant or it don't have a restriction, it just needs more refrigerant. And I would literally tell him, I said, tell you what, why don't you put cousin Bill on the phone with me and I will school him on air conditioning. I had no problem discussing air conditioning with somebody. No problem. Because 99% of the time, I know that guy doesn't know his head from his ass about air conditioning. So if I put my head pressure, my suction pressure, my superheat, and my subcooling on this paper, and I took a picture of my gauges, and you call me 3 weeks from now, and cousin Bill said it don't have a restriction, it's low on refrigerant, and then I'm just trying to screw you, and I don't need a whole new evaporator coil because I just need more refrigerant on the system. Put cousin Bill on the phone with me. Let me explain how air conditioning works. You're not going to prove me wrong because I got a damn picture. Now, I have nothing on there. Cousin Bill says it's just low on refrigerant. He goes and adds refrigerant to the system, drives his head pressure up, gets his suction pressure to where it's better than what it was, and they're cooling better. Cousin Bill was right.
But he didn't do what was right.
Prove it. It's cooling better now.
You don't have any physical or visual proof. So they're going to take his word for it.
If I had my
If
pictures,
you
if I had my
If you
pictures,
hadn't had your pictures, that would have been, Cousin Bill was right. We ain't calling Eric no more.
right? But my pictures, I can sit there and debate with you.
Well, we're
Now,
not debate.
what if I have pictures of my system before I added refrigerant and after I added refrigerant, and Cousin Bill says, that system wasn't low on refrigerant, I charged that system myself. They screwed you out of $500.
You got,
So now the customer calls back and goes, Cousin Bill said you screwed me out of $500. That system wasn't low on refrigerant. I want my $500 back. I go, no ma'am, we're not giving you $500 back. Here's a picture of your system before, when I got there. Here's a picture of your system when I left. And this, I can prove that it is correct pressures and temperatures. And I can also prove that Cousin Bill didn't lower the blower speed because it was a 5-ton furnace and it's really a 3.5-ton condenser, and then you were blowing 2,000 CFMs of airflow. Now we're blowing 1,400 CFMs. So Cousin Bill overcharged the system with the 5-ton airflow, and I reduced it, and I let refrigerant out of the system. I recovered the refrigerant out of the system, and Cousin Bill had it running on 5 tons. Look, take pictures, guys. CYA, every time. CYA, CYA, CYA. Trust me, pictures have pulled me out of more shit because you go out there and do it. I didn't do it. I don't know what you've seen. And depending upon who you are, will determine of whether I truly believe you or not. Because I may not believe you that your pressures were what they were.
So sorry, just a reminder that you have a 4:30 appointment.
Did I?
It says 4:30.
Oh, okay, yeah, I do.
Okay.
Just remembered about that. What time is it?
3:30, little after 3:30, so you still have 55 minutes, okay?
Good, that's perfect. Thank you.
You're welcome.
that makes me feel good about the 471-pound pressure that I took a picture of.
Yeah.
I mean, it's.
It could be a
it's
malfunction
that-
in the gauge.
Yeah,
It could be anything.
but at least you could see it did read what I had said and all the other information. So that,
So look, guys, how many pictures should you take when you go out and you do a PMA? Think about it. You got horizontal unit. No. You really can't. Because I want to see the installation of the system. I don't care if we installed it or not. Take a picture of the installation of the system. Take a picture of the condenser. Okay? You check an electric heat system. Take a picture of your electrical. Alright? Upload all that stuff, and actually when you upload it, you got to name it. Well, I want it named, okay, disconnect box, electrical disconnect box. I want it named installation, air handler installation, which tells me if I go look at it, I'm looking at the installation of the air handler. Okay?
every picture.
Supply plenum wrong. Or supply plenum missized, and whoever put a supply plenum in, they got transitions, duct board blocks off, all that kind of crap. You're taking a picture of it because you want a recommendation to replace that supply plenum. So I have a picture of it. Customer calls me back 2 weeks later and says, your guy said I need a new supply plenum. Well, let me go look. Yeah, I got a picture of it right here. Yes, ma'am. Now I can talk to him. and I can explain to them why you need a new supply plug. You got air leaks in your return area, your return's falling apart. Yes ma'am, I got a picture of your return area, everything's falling apart. This is why we need to rebuild the whole 9 yards of it. Yes ma'am. Your return area is not sealed. Yes ma'am, we got a picture of it right here, your return area is not sealed. That's why we have a recommendation to replace it and repair it. Okay? So, we're gonna wrap it up right here because I got a meeting at 4:30. So, this video here is the electric heat system on the fall PMA. Guys, I hope you, one, have enjoyed just the training on here. I put a lot of time and effort trying to teach the electric heat system, gas system, the PMAs. Our next video is the finishing of the PMA. Because all we've done so far is literally check the heaters, and we haven't checked the rest of the PMA. We haven't done the duct system, the drain lines, and all that kind of stuff, which is on our PMA. So there'll be 2 videos you gotta watch if you do an electric heat system. One is on the electric heat system, and the other is the duct portion of it and the rest of it. Or if you're doing a gas furnace, you gotta do the gas furnace video and then the duct portion part of it and the airflow part of it. And you put those 2 together, and then you learn how to become a technician. You learn all these little stories I'm telling you guys. You know what you need to do? You need to use the stories sometimes. Because when you go into a customer's house, you don't have a story. You don't have a story of that duct system that was falling apart and mold all over. You don't have that story yet. Use my stories. Okay? Use the pictures on that folder that I just showed you. That's the story. Use the pictures. Okay? I got pictures of the units, okay, inside there, where you can tell different types of systems and stuff. That's why I put all that stuff, guys. So this is going to conclude this video. Till next time.